Hey everybody. In class lately we've been solving a lot of equations using addition and subtraction. Tonight we're going to learn about another tool we can use to solve different types of equations. This tool is called the division property of equality. Just like we have the addition property of equality, which says we can add the same number to both sides of an equation and both sides will stay equal. And we have the subtraction property of equality, which says that we could subtract from both sides of an equation. We also have the division property of equality. The division property of equality says that dividing both sides of an equation by the same non-zero number produces an equivalent equation. This non-zero part is important, right? Because we can never divide by zero. Dividing by zero doesn't give us an answer. It's undefined. So let's say we have p equals 8, right? Let's say I decide to divide both sides of this equation by 2. I divide p by 2 and I divide 8 by 2. That gives me p divided by 2 equals 8 divided by 2 is 4, right? But because I started off with p equals 8, right? If I put 8 in here for p, this equation would still be true. It would give me 8 divided by 2 is 4 equals 4, right? If we divide both sides of an equation by the same number, the equation stays true, right? If we have c equals d, I can divide both of these by the same number. I can divide both of these by x, and the equal sign is still valid, right? C divided by x is the same as d divided by x if c and d were equal to start. Let's take a look at how we can use the division property of equality to solve equations. In our first example here, we have -3 times x equals 45. This is an equation, but it's kind of different than the ones we've been solving, right? There's no addition or subtraction happening here. The only operation that's happening is multiplication, right? -3 times x. So we're going to have to use the inverse operation of multiplication, which is division, right? Just like we undid addition with subtraction, or we undid subtraction with addition, we can undo multiplication with division, because multiplication and division are inverse operations. So I'm going to divide by -3 here. Now, the same rules apply. If we divide by -3 on one side, we have to divide by -3 on the other side. That's how the two sides of the equations stay equal. Now think about it. If I divide -3 by -3, that's going to give me 1x. So I'm going to have 1x over here. Remember, if it's 1x, I don't need to write the 1. 1x equals 45 divided by -3 is -15. My answer to this equation is x equals -15. If I want to check it, I can substitute it for x. -3 times -15 equals 45. Is that true? -3 times -15 is indeed 45. -15 is the value that makes our equation true. That's the solution. Okay? Our second example here, 6 times a equals 54. We're going to solve the exact same way. We'll draw a line down through the equal sign. Since we see multiplication here, we're going to use the inverse operation of multiplication, which is division. Divide by 6, divide by 6. 6 divided by 6 is 1, so we're left with 1a, or just a, equals 54 divided by 6 is 9. Now, I want to double check this. I'm going to plug this 9 back into the original equation. Substitute it in. 6 times 9, because a equals 9, equals 54. 6 times 9 does give me 54. So 9 is the value that makes that equation true. So I know that I found the right answer. These next two problems, we're going to solve the exact same way. We'll draw our line. -13 times b. We'll use the inverse operation, which is division, divided by -13, divided by -13. Negative 13 divided by negative 13 is 1. We have 1b equals negative 5. 65 divided by negative 13 is negative 5. And now when I substitute negative 13 times negative 5, I get 65. Always a good idea to check our solutions to make sure we didn't make any mistakes. All right, our last example here. Ooh, this one's a little tricky now. Negative c equals 16. Now, we've seen problems like this before, where we have negative and then just a variable. And remember, we can think of there being a number in front of that c. We can think of there being a 1 there. So this is like having negative 1 times c. So if this is negative 1 times c, I'm going to get rid of that negative 1 by using the inverse operation. I'm going to divide by negative 1. Divide by negative 1. Now when I do that, negative 1 divided by negative 1 is 1. So I get 1c equals negative 16. Forgot to draw my line there. I always want to have that. c equals negative 16. Now let's substitute here, and we'll see if this makes this equation true. We have negative, and then for c, I'm going to write negative 16 equals positive 16. Negative 16, that's like saying the opposite of negative 16. That just gives us positive 16 equals 16, right? Think about this as subtracting negative 16. That's just like adding positive 16, right? So we go right there. 16 equals 16. So c equals negative 16 is the correct answer. All right, that's all the notes we have for tonight. Just those 4 examples and the division property of equality. Make sure you write your questions and your summary and submit those notes through Canvas. And I will see you guys in class tomorrow.